Okay, lesson 3.2. This lesson we're going to be learning about standard form of our quadratic and also a bit about factored form as well, and going between those two, which should be skills that we already have, factoring and expanding. So recall what's the equation of a quadratic function in vertex form. Explain the meaning of each part of the equation. You should try and do this on your own first. Pause the video. We have the equation y equals a, x minus h or p squared plus q. Please try and write it. I don't mind if it's h and k there, but everything else should be exactly this way. You should have an a in the front. You should have the minus sign. If you don't have the minus sign, you're doing it wrong. And a plus at the end. So a is the vertical stretch. And flip. That determines how sharp the U shape is, or if it's upside down. The P is the X value of the vertex. And Q is the Y value of the vertex. You should get very, very comfortable reading P and Q, reading the vertex from this. This is going to be a major, major part of 30-1 when you do transformation functions. So P is always the right way around, but in the function it's going to look backwards because it's a minus sign right there. So everything inside the brackets is always backwards. So quadratics in standard form. Two ways to look at it. So this is just completely expanded out is what we call standard form. And there will always be a term with an x squared, there'll always be a term with an x, and there'll always be a constant at the end. Although some of these values could be 0. Right? Your c value could be 0, you could just have something like 3x squared plus 2x. And that would still be a quadratic in standard form. The only thing that can't be a 0 is the a. If a were a 0, it wouldn't be a quadratic anymore. This whole term would go away and it would be just a linear function. So a has to not be 0, and sometimes you see that as a restriction. Sometimes they say as long as a is not 0, then this thing is true. This is function notation. You'll learn a lot about that next year. Standard form tells you, we've already talked about this together on the first day, it tells you the y-intercept and the shape of the parabola and the direction of opening. All of this is our immediate information, I call that. Immediate information. You should be able to tell that in about 2 seconds. A is going to be direction of opening and also the shape. If A is a higher number, it's going to be sharper U shape. And if it's a fraction or something, then it's going to be a really wide U. And C is the y-intercept. This is the exact same as the b value in linear functions. If you looked at just this thing, it'd be a linear function, and that again would be the y-intercept. Whatever constant you have is always the y-intercept if it's expanded out. Okay. This next page, if you want to go on Desmos and look at the stuff again, you can, but I think we already talked about this all on the first day, so it just wants you to play around. If you change the c value, what does it do? The c value will change the y-intercept. And we kind of already saw that in action. If you have a c value of plus 10, the y-intercept is going to be plus 10. If the c value is negative 2, the y-intercept will be negative 2. So yeah, whatever c value is exactly what the y-intercept is. What happens when you change the a value? Well, this affects the direction of opening and the shape of the graph, which we already talked about. Direction of opening and shape. And we kind of already know about this. So if a is positive, it opens up. If a is negative, then it opens down. Hopefully you can read these things. This just means whether it's positive or whether it's negative. We've had some questions like that on the test, so we should be able to read that pretty quickly. And I won't write all the stuff about shape, but basically the bigger the a value is, or the further from 0 it is, the steeper the u shape is going to be. Right, because negative 10 is going to be a very steep shape, even though it's very small. But positive 0.0001 or something is going to be a very flat u. And actually, in real life, A values often have a value of something like 0.0018 or something. From what I've seen, when I've tried to map out real life situations before, and you try and calculate what the A value is for this parabola, it very often ends up being very, very small values of A. So very, very kind of slow U-shaped curve. What happens when you change the B value? We talked about this one as well. There's no clear relationship. It kind of just moves the graph. There are some advanced things you can say about the B value if you go far enough in mathematics, but I don't think it's worth the time investment to actually understand what it does. But we saw how it moves kind of on an upside down parabola, where the vertexes will kind of slide along this upside down parabola based on what the B value is. But we don't have to worry too much about the B value. It's more important the A and the C value. Okay, example number 4, identifying characteristics of a quadratic function in standard form. So this is our original y equals x squared. This function we call the parent function, which means if you want to see quadratics as transformations, this is the original one that you're transforming. So this guy is just all the original values, and you should have this one pretty memorized. So making a table of values for this right away. Start with the vertex in the middle, and then usually go 2 on either side. So always start with the vertex there, and then if 1 squared is just 1, 2 squared is 4, and the other side should be the same. So 0, it goes 1, then it goes 2, 4, goes negative 1, 1, negative 2, 4. That's our quick little table of values. So what's the direction of opening? It's up. Say up, or draw a U shape going upwards. The coordinates of the vertex, oh, it's 0, 0. It's the origin. The maximum or minimum value, it is a minimum value of 0. The equation of the axis of symmetry, so that's this guy right here. Use my red one. It's going to be a little bit hard to see. I'm going to put it a little bit to the side so we can kind of see it a bit better. So what's the equation of this vertical line? Well, what's true always, vertical lines can be hard to write the equation for. What's always true for this? Well, the x value is always 0. So x equals 0 is the equation. It says right in the question, I've marked this for many years now, it says the equation of the axis of symmetry, so don't just say 0. 0 isn't an equation, it has to be an actual the equation of the line, which is the axis of symmetry. Otherwise you will lose marks. What is the domain and range? This is a parabola. It's a polynomial, which the domain is always all real numbers. The range for our parabolas, y is real numbers so long as y is greater than or equal to our minimum value of 0. I'll just read this completely out so we understand all the language again. Hopefully we kind of understand this from grade 10. This means range is, so range semicolon, squiggly bracket, which means a group of. It means an unordered set. It's just a whole collection of different numbers. So the group of y's that are real numbers, so the things in this group are all y's that can be real numbers, which is everything, all the decimals, all the fractions, even numbers like pi exist in the real number set, and root 2. So y is all the real numbers so long as y is greater than or equal to 0. Close, that's the group. So that's what that means, and that's a complete sentence. What are the x-intercepts? Well, there's only one at x equals 0. And what is the y-intercept? Well, there's only one, and that's when y is equal to 0. Sometimes you write little subscripts. X-intercept and y-intercept is actually equal to 0 and 0. So that's our original parabola. Okay, so a new one. We're going to try and do all the same things. Number 1, what's the direction of opening? Well, it's up. Number 2, what's the coordinates of the vertex in this one? It's 1. Is that -1? It is good to put a capital V indicating that's the vertex, not just some random point that you're talking about. Number 3, the maximum or minimum value of this one. Well, this is a minimum value of -1. 4, the equation of the axis of symmetry. So what's the equation of this vertical line right here? That's x equals +1. 5, domain and range. Domain is all real numbers. We know that. And range, y is real numbers so long as y is greater than or equal to -1. Should be squiggly bracket. Don't waste a lot of time on this. You should get comfortable with this. I've seen some people, they stare at domain and range questions on the test for 10-15 minutes, and this really should only take about, I don't know, what was that, 15 seconds at most. So if you're not be able to do these things in 15 seconds, especially with parabolas, because it's always pretty much the same way if you're looking at a parabola. If you can't do this really quick, then you need more practice. 6, what is the x-intercepts? Oh, there's 2 this time. So x-intercepts is equal to 0 and 2. There's a lot of different ways to write that. You could write it as coordinates. You could say x-intercepts are 0, 0, and 2, 0. As long as you are clearly communicating that's the intercept you're telling me and where they are. So if you're indicating it's just the x values that you're telling me, that's fine. If you're indicating the whole points, that's fine. One of those 2. What's the y-intercept? That's also 0. Y-intercept is equal to 0. Good. You probably should try this one on your own first. Pause the video, make sure you can do all these things. Okay, so really quickly, it opens down. What's the coordinates of the vertex? It's 1, 9. Vertex is 1, 9. Maximum or minimum value, it's a max this time, is equal to 9. So you need to combine the 2 facts, whether it opens up or down, and the y value of the vertex. These 2 things together should tell you what the answer is here. So you don't even really need the graph, but you can clearly see on the graph that's a maximum value of 9. The highest this graph will ever go is 9. 4, what is the equation of the axis of symmetry? X equals 1 again. 5 is domain and range, everyone's favorite question. Domain is all real numbers. Don't even need to think about that, every parabola is. Range, y is all real numbers, that's always the same, so long as, now you just need to include your information from the max min. Y is always less than or equal to 9. Make sure you have the equals to. It does actually hit 9, it just never goes above 9. 6, the 2 x-intercepts, so x-intercepts of -2 and +4. And the y-intercept is +8. So that's not too bad. We can also find the zeros of both these functions by factoring, and this is a really important thing as well. So I'm actually going to pause here and I'm going to go back for these 2 questions. If I had only the equation and not the graph, and I wanted to find out where the 2 zeros were, 0 and 2, all I would have to do is factor this. So x squared minus 2x. Hopefully we had that review at the very start of the year. Hopefully we can kind of remember how to factor a little bit. First thing you always want to check is common factor. And there is actually a common factor of x. So I'd common factor out x. I'd leave behind x minus 2. And that's actually fully factored now. Now, what we need to do is solve this for when the height is 0. You can't actually solve this original question for 0. It's going to be too hard with an x squared and an x there. We have some really complicated things to do to solve for the original quadratic when it equals 0, because there's going to be multiple solutions. So that we're actually going to leave till much later. I think it's in the next unit when we talk about the quadratic formula is the only way you can do that. But this guy, if you factor it, then it can be solved. Hopefully you guys touched on this a little bit last year in the factoring unit, because that's kind of the point of factoring. I can solve this equation. Basically what this means is I have two different numbers multiplying each other, and together they equal 0. The only way that's possible is if my first number is equal to 0, or if my second number is equal to 0. There are no two other numbers which will multiply to get 0, unless one of them is 0. So this actually means there's two solutions. Either x is equal to 0, either my first number is 0, or my second number is 0. Or x minus 2 is equal to 0, which means x is equal to 2. So these are what we call finding the roots. You should be able to read it quickly from this equation right here. We're going to be able to do this. We're going to do this a lot in these two units. So this one right here means 0 is one of the roots. This right here, usually whatever this number is backwards. So x equals 2 is the other root. And that is indeed the two x-intercepts we found. So trying it again on this one, let's try and factor this. Negative x squared plus 2x plus 8. A little bit harder to factor. First of all, it's not even a simple trinomial because we have a negative in the front, but we can actually fix that by common factoring a negative 1 out. That means you flip the signs of all the terms, and you should end up with a polynomial like that. So if you had to rainbow it back in, or distributive rule, it'd be negative x squared plus 2x plus 8. You get back to the original. Now we need to factor this, and this is a product sum rule. Product sum. So it has to multiply to negative 8, and it has to add to negative 2. So what two things, you always start with the multiplying. What two things multiply to negative 8? Well, 1 times 8, 2 times 4, 3 times, nope, doesn't divide by 3, and 4 times 2. These are actually my only two sets. Usually there aren't that many options. One of them has to be negative, and they have to add to negative 2. So it should be this set right here, if 4 was negative. Since it's a simple trinomial, those are my two magic numbers, I call it. It factors like this. X plus 2, x minus 4. And that's done. So that's completely factored. If we're trying to find the roots, so now we're saying this equal to 0, what values of x would make this whole thing become 0? Well, my two numbers I could sub in, if x were negative 2, this would become 0. That'd be one of my solutions. And also if x was positive 4. And that is indeed our two roots. So we should be able to do it with the original equation from standard form if we factor it into factored form. Okay. Slightly harder one. 2x squared minus 12x plus 25. So number 1, it goes up. Number 2, it has a vertex of, we want to know exactly what that point is. Well, it looks to be exactly at the point 3. There's a way we can actually tell that a little bit better. Look for points which are actually going through intersections, through lines. So that's at 1 and that's at 5. Those two we know for sure are at 1 and 5, and they're the exact same height. So that actually is going to help us. It means the vertex has to be exactly halfway between them. So what's halfway between 1 and 5? That is indeed 3. So the vertex starts at 3. That part we can know for sure now because we have 2 going through lines. What about the height of it though? That's going to be a little bit trickier. We can just sub it into the equation though. So if we know the x value is 3, all we have to do is sub that into the equation. So what is f of 3, we call it, which is 2 times 3 squared minus 12 times 3 plus 25. So you sub 3 into the original equation and you solve. Make sure you're not multiplying 2 times 3. That's probably the only place where most people would mess up if you're going to mess up. You have to do the squaring first. This part right here has to happen first. If you put it all in your calculator at once, your calculator should do it in the right order. If you have brackets around the 3 and just the 3 squared, it should work. And the answer you should get is 7. What is the maximum or minimum value? So it's a minimum of 7, a minimum y value of 7. Number 4, what is the axis of symmetry? So we have our dotted line, and that is x equals 3, equation of it. So x equals 3. Domain and range, everyone's getting really good at this. We don't actually usually go through this much practice, so you should be very good at it by the end of this lesson. As long as y is bigger than or equal to 7. It's always bigger than or equal to 7. Good. 6. What are the roots? Let's try and actually do this by factoring. Oh, actually, we got a problem with this one. We can't factor it. You don't know that yet, but if you try to factor it, you're going to fail. But the easier thing we can say is the roots are the x-intercepts, and that does not exist. The roots do not exist, or you can say that there are none. And our last question, what is the y-intercept? Looks to be a whole number, looks to be 25. That's actually really easy to find. We don't even need to, you could look on the graph, or you could sub in the value x equals 0 if you're trying to find it, or you just look, if you sub in x equals 0, of course it has to be whatever your constant is at the back, right? That should always be the case with your y-intercepts. They're the nice ones. Same with these previous questions. This one was a y-intercept of 8. Hey, the 8 was right there at the back. I forgot to check this with the equations, but yeah, it should be really, really easy to find. Functions in standard form. So we're nearing the end of the first lesson. Oh, we're missing something there. Oh well. Write each function in standard form. Is it a quadratic function? So now we need to be able to expand. Hopefully we can remember our FOIL. FOIL is an acronym that says first, outside, inside, last. So in this one, we want to do, it's kind of in the wrong order. X's are at the back, usually they're at the front. We'll just rearrange it at the end though. First is the first thing from both sets of brackets. So that is, what is 5 times 6, which is 30. So that's our F taken care of. O is outside, which means the two things farthest away from each other. And when you're doing these, make sure you always keep the sign that comes from in front. This minus belongs to the x. This minus belongs to its x. There's a plus with the 5, and there's a plus with the 6. So 5 times negative x is negative 5x. Inside is the two inside ones, the two ones closest together, within from different sides of from different brackets. You never multiply 5 times negative x here. So negative x times 6, negative 6x, and negative x, L is the last, negative x times negative x, which is positive x squared. Rearrange and simplify. There's always two terms in the middle, usually two terms in the middle, which collect. So this should be x squared minus 11x plus 30. Is it a quadratic? Yes. It's a quadratic because it's a second degree function. We have x to the degree 2. Okay, expanding this guy. Ooh, what do we do first? You could do it in any order you want, really, as long as you don't do it twice. So you could multiply x into the first set of brackets, or you could do the FOIL first. Either way is fine. The only thing that you could do that is wrong, that I see some people do, is they take this x, and they multiply it against the x, multiply against the 3, and keep going. They also multiply it against this x, and multiply against this -2. That's too much. If you do that, you've gone too far. You actually only multiply each set once. So I'm actually going to rainbow this in first, but only into the first set. You only multiply it once. So that'll become x squared plus 3x. X minus 2. Then we do our FOIL. So x squared times x. X squared times -2. Positive 3x times x. The degree of it always goes up by once when you're multiplying two x's. This is kind of like your exponent rules, or you count. X times x is 2x's. 3x times -2 is -6x. Collect your like terms. X cubed plus x squared minus 6x. Is that one a quadratic? The answer is no. This is a degree 3 function. This one is actually cubic. Cubics operate a little bit differently. They're not going to make a parabola. If you wanted to look at this one, it would make some kind of, I don't know what shape you call that. It basically has kind of two vertexes. And it's going to go up, then down, then up again. Okay, so try the first assignment questions. That's it for this lesson. Quite a bit to learn, but probably not as bad as the vertex lessons that we did.